So today we're still working on these word problems. The first couple examples I want to do are very similar to the mixture, except they are going to involve interest. We're going to still use the table to help organize all of our information, so that's why I say it's similar to the mixture. When we're talking about simple interest, do you guys know the interest formula? So it's principal times rate times time equals interest. Just as a side note, when you're setting up tables, make sure your labels, or you have to have labels on your columns and your rows. Okay, so you're not just stacking up a bunch of numbers. In your head, you may know what they are, but if I don't, then that doesn't count. So you have to label all of that. So this would be the formula we would put across the top. Remember last week when we were doing the mixture problems, what formula did we use? Amount times the concentration, which is the percent, equals the amount pure. So we've seen a couple different formulas at this point. So those are the labels that would go across the top for your columns. So let's look at an example. Sarah has $70,000 to invest and requires an overall rate of return of 9%. She can invest in a safe government insured certificate of deposit, but it only pays 8%. To obtain 9%, she agrees to invest some of her money in non-insured corporate bonds paying 12%. How much should be placed in each investment to achieve her goal? Alright, so you might see the reason that I said we're still going to use the table is there's a lot of information here. I'm talking about multiple percentages. We have to have some way of kind of keeping our information straight. So that's where the table can be super helpful. So across the top, we have principal times rate times time equals interest. So now my labels on the sides, those you have a little more leeway. You can call it first, second, and total again. We can name them by their percents. She's going to put some in the certificate of deposit, some in the bonds. So however you want to label those, so I'm going to call them the CD, the bond, and the total. But you don't necessarily have to have the same labels there. Now we start trying to figure out where we put information here. So Sarah has $70,000. Where would that go? Where at? The CD, the bond, or the total? Total. It's what she has to start with. So principal is like your beginning amount of money. So altogether, she has $70,000 to begin with. All right. So she requires an overall rate of 9%. So my rate, those are my percentages. Is that the CD, the bond, or the total? Total rate would be 0.09. She can put some in a CD. I don't know how much, so that could be X. Okay, the rate of the CD is 0.08. Okay, the rest of it is going in a bond, and the rate for the bond is 12%, so 0.12. All right, we're making progress. If there is no mention of time in any of these interest problems, then technically you could do any amount of time as long as they were all the same. So usually I just do 1 year unless the problem specifies otherwise. So it's going to say time of 1. So what would be my principal for the bond? We have $70,000 altogether. We're putting X of it in the CD. The total minus the amount you already spent. All right, so then to get your interest, we just multiply. So X times 0.08 times 1 is 0.08X. And my 0.12 times the 70,000 minus X. 70,000 times 0.09 times 1. And then the equation is just like the others. So we have the first, the second, and the total, so we're going to use this final column. And how do we write the equation from it?
0.08x plus 0.12 times 70,000 minus x is equal to 6300.
Subtract over my 8,400. Divide. Hmm?
52,500.
Okay. Now we have to answer the question. The question was how much should be placed in each investment. So this is where the labels are really important. So I know X was the amount in my CD. So Sarah needs $52,500 in the CD. And to find the other one, the bond was 70,000 minus X. So 70,000 minus 52,500.
17,500.
The bond. So different formula across the top, but otherwise it's pretty well the same type of setup as we were using on our other problems. happens there. All right. Let's take a look at this. Linda won $200,000 in a state lottery. She first paid income tax of $30,000 on the winnings. Of the rest, she invested some at 1.5% and some at 4%, earning $4,350 interest per year. How much did she invest at each rate? So what do I do? Make a chart. We're talking about interest, so I know I need a chart with the interest formula across the top. Principal times rate times time equals interest. Okay, so if I go back and read this, she won $200,000, but the very first thing she did was pay a 30% income tax. So did she ever have $200,000 to invest? No. Think about your paycheck. You never even get that money. Okay, the taxes are taken out before you get your check. So I don't want to use $200,000 as my total principal. What do I need to do?
Multiply that by 0.3.
Okay. So if we want to find the amount of tax that she had to pay, we can take the principal, 200,000, times 30% or 0.3, and you get
60,000.
so 60,000 was gone to begin with. All right, so my labels, we can call them whatever we want. I'm just going to do first, second, and total. So for my total principal, she had 200,000. She paid $60,000 in tax. So how much money does she actually have to do something with? You do the 200,000 minus the 60,000. So the 140,000 is the beginning amount of money. And now I'm pretty much done with those first two sentences. Okay. She invested some at 1.5%. Do I know how much? So that's my X, my rate.
0.015.
Some at 4%. Can I call that one X as well? No, what would it be?
1,440. 140. Yeah. Right.
And that one is 4%, 0.04. Earning $4,350 interest per year. So did I give you the interest rate? No, I just told you how much interest she's going to earn from that. So, where would that number go? Yep, it's the I for the total. Okay, it was per year, so my time would be 1 year. All right. So we haven't seen this happen before, but I do have a box and I don't have a number here. But it's okay, because our goal is to get this final column. So since I have the total interest, it's okay that I don't know that rate. We just need to get everything in this last column, so now we multiply. So x times 0.05 times 1 is 0.015x. 0.04 times 1 times 140,000 minus 6. Now, the equation kind of writes itself. You add the first and second to equal your total. okay to this point? If now it is combined in terms, so 0.015 minus 0.04 is negative 0.025. 4350 minus 5600. Negative 250. $12.50. And then we divide. So X is 50,000. The question was how much invested at each rate. So X was the amount at 0.015. $50,000 at 1.5%. And to get the second one, we have to do 140,000 minus X. So 140,000 minus 50,000. And that's our amount that works. What questions do you guys have for me right now? Doing okay with those? Such a good friend. All right, I want to do one other type of problem today, and then I'm going to give you guys a chance to practice. So these problems are probably going to be a little bit nicer than what we've been doing, much less involved for sure. We're not going to have to set up quite as much information here. So when I'm looking at this problem, Peripheral Visions Incorporated offers downloads of live concerts. The company places an ad in a trade newsletter. The cost of the ad is $100. Peripheral Visions Incorporated pays the performer $20 per download, and the company charges $24 for each customer downloading the performance. So A, express the cost C as a function of X, the number of downloads sold. So we are writing an equation for cost. And this is just a linear equation. Cost as a function of X, so C of X. Remember equations, y equals mx plus b, so you did this in Mrs. Keller's class. When you're looking at this, we really just need to find m and b. And remember, b is the y-intercept. It's like a one-time fee. Your m, your slope, that is a repeated cost. So we just need to look back at this problem and dealing with the cost, see if we can figure out what our slope and y-intercept would be. So, for the company, what is their one-time cost? That's for the people buying it. The company places an ad for $100 and they pay the performer $20 per download. Okay, so those are the two numbers. Which of those two fees are they paying over and over again? The $20. Every time there's a download, they pay $20. So that's the slope. So it's 20x plus B, the one-time fee. They place that ad one time. So that's my 100. B, express revenue as a function of X. Revenue is the money you're bringing in. Not necessarily your profit, but the money that is coming into the company. What are they getting paid?
24.
They get paid $24. Is that one time or repeated?
Yeah.
Repeated. Every time it's downloaded, they get $24. So that's my slope. Is there a y-intercept? Is there any lump sum payment that they are receiving? No. So my y-intercept is just C right there. My revenue is just 24x. C. For what value of x does revenue equals cost? This is sometimes called the break-even point. Okay, you guys know if you're going to run a business, you want to bring in more money than you're paying out, right? You want to make a profit. So to do that, we need to know at what point am I going to break even? How much do I have to sell so that I'm not losing any money? And then everything beyond that would be creating a profit for me. So to find that break even, we just want to know when does revenue, which my revenue was 24x, equal my cost, which was 20x plus 100. Subtract over the 20x, divide, and x is 25. So 25 downloads is our break-even point. That means if fewer than 25 people download this, the company has just lost money. If more than 25 people download it, they made a profit. They make money. Is that okay?
Honestly, I wonder if they would make that. They would make that with Spotify. Everyone just supposed to start
I
dancing
know.
on Spotify.
All you people trying to get things for free. Alright, see if you guys can do this one. So we have a baker that's selling cakes. Her initial cost to enter the fair was $40. She figures that each cake costs $2.50 to make and she charges $6.50 per cake. So A, express the cost as a function of x. X is the number of cakes sold. So M, what is the repeated cost that she has? The $2.50. She pays that for every cake. And what is the one-time cost? $40 to enter the fair. Revenue, how much does she get paid?
$6.50.
Okay, that's our slope. Is there any one time? No. So C, we want to know when revenue equals cost. So we'll subtract over the 2.5. X is 10. So she has to sell at least 10 cakes to break even. More than that, she makes a profit. Any questions there? So I'm going to stop here for today. Tomorrow we're going to wrap up just a couple more practice problems, do some review over everything. Wednesday we're probably going to review this a little bit more, try and practice it all, and we'll probably do a quiz on Thursday. So that's kind of our plan. So for today, same handout we've been working on. I'm giving you so much each day. So I want you guys to do 8 through 10. Well, let's see. Yeah, let's just do 8 through 10. We're not going to